Alright, so it's level 1B. Now we can go a bit faster. So the figure shows a balance. Again, balance means you can apply POM, which means that sum of clockwise movements equals to sum of anti-clockwise movements. And again, this is a uniform meter ruler. So uniform means the weight acts from the center, but because it's pivoted at the center, right? So the moments due to this force will be 0, so we can ignore its moments. Alright? Now the 0.1 Newton force is at the 20 cm mark, and then you have a 0.2 Newton force at a certain mark. We don't know the distance from the pivot, so we call that distance D. Now again, first thing, decide what direction do these forces cause. So this anti-clockwise and clockwise. So when you write this out, you can then sub in the values for clockwise movements, which is 0.2 Newton multiplied by D. It will be equal to the anti-clockwise movement, which is 0.1 multiplied not by 20, but by its distance from the pivot, which will be 50 minus 20, 30. Take note all this are in cm, so the final D you get will be in cm. Now, question asks for position. So again, for position, we cannot just leave our answer at D. We need to add in the 50 cm mark plus D to find the actual mark, which is the position, to put these weights. Alright, so you'll be at a 65 cm mark. Now question 2, again you have uniform and equilibrium. So again, uniform means the weight acts from the center. Now how do I know this is the center? Because this is 4 meter to the left, and there's 4 meter of the rod to the right. So this is at the center. Now again, because the weight is directly above the pivot, it means that this weight will cause 0 moments about this pivot. So we can ignore the moments due to this weight, right? So equilibrium tells us we can apply this. So again, this force multiplied by the 2 meters plus this force multiplied by the 4 meters is equal to the 10 Newton force multiplied by its distance from the pivot, which is 4. Now take note again, you can't do this method where you take F plus 6 multiplied by the total distance, which is 4. You cannot do this, okay? So what you have to do is simplify this, and when you simplify, you get F equals to 8 newtons. Now question 3, again, you have a uniform beam. So uniform again means that the center is where the weight acts. Okay, but because this beam is again pivoted at a midpoint, so once again we can ignore the moments due to the weight of the beam. Now where can we place a 50 Newton downward force such that we balance the system? So here we have a 40 Newton force. Now what moments does this cause? Clockwise or anti-clockwise? So it causes the anti-clockwise moments because it will cause your beam to rotate this way about the pivot. So in order to balance this, of course, we know we need to put a box or a downward force here in order to balance it. So I've drawn it here. Do I know the distance from the pivot? I don't know. So I put a D there. Now again, we identify the anti-clockwise and clockwise moments, and then we sub in the values 50 times D, where D is the distance from the pivot, equals to 40, the force multiplied by its distance from the pivot. Simplify, D is 16. 16 what? Well, it depends on our units used earlier on. So here, 20 is in cm, so therefore my distance will be in cm. Finally, because they want the position where, so we have to explicitly state where. So it can be placed 16 cm to the right of the pivot. Question 4 again. The barrier is pivoted at P. In order to make it easier to raise the arm, the weight of the arm is balanced by counterweight M. Okay, so this is counterweight M. So again, clockwise is due to this force, anti-clockwise due to this force, sub in your values, but because this is the mass and not the force, we change gram to kg by dividing it by 1000. We multiply by 10 to change the kg into force, the weight. because W is mass times gravitational field strength, where G is just 10. Now you multiply by its distance from the pivot. What's the distance from the pivot? Is 2.4 equals to W multiplied by its distance from the pivot. W is 1200 newtons.